So throughout this 3D Collisions in GameMaker series, I've tended to shy away from actual gameplay code with some basic exceptions, such as when you walk around, you want to be able to collide with walls so that we can show off the system working in the first place. But there is one bit of gameplay relevant logic which I would like to talk about at some point. It tends to come up a lot, and that is the subject of if you have something like a ball, like that one, and if you have the ball hit a wall and you want it to bounce off the wall, how do you do that? So this is a bit of general logic that applies not only to balls and like sports games, although if you are making a sports game, you will almost certainly have to deal with it at some point or another. This can also pertain to things like ricocheting bullets, or if you have like a laser and you want it to reflect off a mirror, or if you want to, God forbid, do something that vaguely resembles ray tracing or path tracing. This is a little bit of math that you're going to come to like quite a lot. As it happens, this is a very simple bit of code. This is a very simple equation to reflect a vector off of a surface. You may have even seen it before, and that is this. So in English, that means that the output vector is going to be equal to the input vector minus the normal of the surface of whatever it hit, multiplied by 2 times the dot product of the original vector and the normal. And we can turn that into code pretty easily. And this will work in pretty much any 3D collision system. I'm obviously going to be showing this off with the one that I've been writing. But if you are using, for example, in GameMaker, the Snitter's 3D collision system, or if you're going to go back and use the old Bullet extension for GameMaker, or the even older P3DC extension for GameMaker, as long as you can do a raycast and you can have that raycast return the surface normal of whatever the vector hits, then you can do this. If you're writing your own game engine from scratch, you can even do this pretty easily, as long as you can figure out that answer, the contact normal of the raycast, and I guess by extension the hit location of the raycast. So let's dive into it. So first, I'm going to, instead of drawing all of the actual like trees in the world, I'm actually going to, for this example, draw just the collision shapes, which is pretty much all going to be just blocks representing the trees, and that is because our collision shapes here are just going to be these blocks, and unless you want to, you can totally have this work with whatever shape that you want, whatever shape exists in your 3D collision system. You could totally have this work with triangle meshes if you want, but since everything else in this collision world is just an axis-aligned bounding box, I'm just going to draw those for the sake of simplicity. Next, moving over to the code where the actual ball object is evaluated and updated. The way that this works, a quick recap, is going to be we are going to cast a ray in the direction that the ball is moving from the ball's position. If the ray hits anything, we're going to figure out if the distance to its hit location is less than the velocity of the ball. And if it is, then we're going to assume that the ball is going to hit something in this update, and we're just going to have it move to that position and stick to that position. And if that isn't the case, then we're going to just add the ball's velocity to its current position. This really should be velocity. I don't know why I call this direction, because direction usually implies like an angle or something like that, while velocity usually implies a vector of some sort. Anyway, so these two lines here, lines 44 and 45, these are all we're really going to change here. Let me comment both of these out, and I'm going to, I guess I'll leave the aforementioned equation at the top half of the screen here, because it's fairly important, and it's going to be what we're going to be spending our time on for the next 5 minutes. So first I'm going to write this out in like pseudo-English, and after I do that, I'm going to adapt the code to actually use my vector arithmetic methods that I've set up in the system. If you are not using my 3D collision system, then you may have to adapt this to however your 3D collision system of choice will deal with vector math, or whatever the case may be. So let's say self.velocity, this is going to be our new velocity, is going to be our original velocity, and we are going to subtract the contact normal, so the normal of the surface that we hit, which in my case is going to be raycast result dot normal, and we're going to multiply that by the product of 2 times the dot product of our original velocity and that contact normal. Are the parentheses in the right place? They are. This is usually assumed to be the case, but our contact normal needs to be a vector of unit length 1. If its magnitude is not 1, then the speed in which we come out of this collision will be different than the speed which we go into it with. This is the logic of what we're doing. This is all it is. Let me real quick just actually use the, for example, vector multiply methods for the normal of the raycast hit result, and this term here, which is a scalar, which is the dot product of velocity and the normal. Likewise, that dot product between that velocity and the normal also needs to be a vector method, which is going to return a result, and the subtraction over here at the beginning, this is going to need to be self.velocity.subtract, because the way that I've implemented this vector arithmetic is a bunch of methods attached to a vector class. GameMaker does not give us operator overloading, so you can't simply have the minus sign work for scalars and vectors and whatever else you want, but we can make do with this. So the other thing I'm going to do is I'm going to if you set the ball's position on contact equal to exactly the point of contact where the raycast hits the wall, and if you try to have the ball bounce, then you tend to get some strange jittery results. Let me just show that off. I think the best way to demonstrate this will be to actually have it happen in the game. Let's minimize that, and there it didn't do anything. I'm looking for some place where it's really going to jitter. Okay, that did it. So you can see the ball is behaving a little bit erratically when it hit that collision box instead of actually bouncing off it, and that is because if you set the position of the ball to exactly the hit location and then change its velocity, then the next update, the raycast between the ball and the world is going to return a hit at exactly the ball's position, and it's kind of just gonna either stay there and not move even after its velocity's been updated, or as you saw, it can bounce around erratically every frame. So the most common way to get around this is to, instead of setting the ball's position to the raycast hit location exactly, one, you can add your new velocity to it. This will cause the ball to appear to bounce a little bit harder off the surface than you might expect, and it might be, you know what I really should do is I really should reduce the number of objects in here so that it starts up a little faster. Anyway, so if I let this bounce around a little bit, and it's going. All right, let's try that again. Try and keep it in the field this time. The ball will appear to sometimes bounce a little bit harder because it is traveling farther on the frame in which it does the bounce, because in this case, not only are you traveling to the wall, whatever that distance happens to be, but you're also traveling the distance away from the wall in that same frame. Let's see, how do I reduce the number of objects? All right, let's cut this down to like 1,000 trees instead of 3,000. That sound good? So instead of adding the ball's new velocity to the raycast position, you can instead add, for example, and this is probably the most common way, but you can add the normal of the raycast hit location.
Hey.
And that will offset the position by exactly 1 unit. And if your world space units are relatively big, that won't really be noticeable. We're going to let the ball bounce around a little bit. Took a funny bounce off the actual triangle mesh tree in the middle, and there it goes flying off into the distance because one of the triangles that it hit was angled. This is really satisfying, I have to say. All right, where'd it go? All right, it's not coming back. Let's break out a new one. There's another use of this. If you want to literally make the game a breakout, you would you do something like this. Anyway, that way the ball does not appear to move a little bit farther on the frame in which it hits the other object than it should. And if you really want to get into it, you could figure out the distance between, what is it, distance to, is it point? Breakcast to information, point, yes. So you can figure out the distance to the point of contact. You can figure out the distance remaining by saying self.velocity.magnitude minus the distance we've traveled. And then to be really thorough, you can add self.velocity.normalize multiplied by the distance to go. That needs to be .mul. Multiply by the distance to go, and this will advance our ball's position away from the wall by the exact amount that it has left to travel in that frame with a given velocity. And that's probably the most correct way to do it. It is a little bit more elaborate, but it will likewise get the job done. We can have the ball zipping around. That's going to go, hello, goodbye. Alright, that one's never coming down. I have not implemented gravity in the system, in case you can't tell. So if the ball takes a funny ricochet off this off that tree, then it's gonna sail off into space forever. If you want to be the most thorough, you might want to take like the maximum value of distance to go and like some small amount, just to avoid the problem that we had at the beginning. But now we're splitting hairs. You can, of course, make this system fancier and fancier to accommodate your needs if you really want a fully fledged like physics simulation. But I am not running a fully fledged physics simulation. And after doing this for 2 years, I'm not sure if I want to. Anyway, that's going to do it for me for today. This is hopefully one of the simpler videos that I'm going to be including in the 3D Collisions playlist. It's technically not super relevant to 3D collisions in GameMaker. You could make like this logic part of the raycast class or the line collision shape class or something if you wanted to. I don't know if I'm going to. I'm going to end this off here. My name is Michael. I like wizards and dragons and making games. If you want the code for this, look for the GitHub repository in the video description for both the 3D Collisions project itself as well as this test world here. I try to post about 2 game dev videos a week, one tutorial like this, and one Let's Make a Game, although the latter is a little bit on hold until I finish this 3D Collisions in GameMaker series, hopefully in a week or 2. So if any of that appeals to you, feel free to subscribe. I hope you all found this useful, and I will see you all later. Special thanks to Zenjamin, VitroV, Squarecrow, Syndra Larson, Manta Ray, GameMaker, Edward Holt, DJ Gibbles, and Army Armbuster for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.